5.3, solve polynomial equations of any degree. This is what we've been building up to. So if you remember, before Thanksgiving break, we learned all of the theorems that were needed. So we'll talk about those as we go. And then we reviewed how to solve quadratics, reviewing the quadratic formula. That was last time. So 5.1 theorems, 5.2 solving quadratic. If you need any help on that, let me know. But today is the main goal of the unit, that you can solve anything. So kind of think about your mathematical background. In 7th grade, you started learning how to solve equations, right? So you had like 3x plus 5 equals whatever, and you had to get x alone, and you mastered that. And then last year, and you spent a couple of years working on it, right? And then last year, you learned how to solve quadratics. So whenever there's an exponent of 2 in the equation, and you learned how to solve by factoring, right? So we're going to take those skills that we learned, we're still going to build on those, but now we have an extra piece, okay? So using the fundamental theorem of algebra, as we look at the notes, we're going to remember that we're going to have 3 roots, 3 solutions here. And sometimes, you have learned how to deal with cubics before. You'd factor it out, and then you'd have that missing piece, right? All right, so we're going to begin with something that you're familiar with. So some of these polynomials that you've never had to solve before, but you can use the same skills. So we are going to look at this and see if we can factor. Now there's 4 parts, so the only way we could factor this is to factor by grouping, and that's when you look at it as the 2 groups. We look at this first group and we see if it has anything in common, and we notice that, yeah, they both have at least x squared, which leaves us with x minus 2, if we pull out the x squared. And then we always bring down this symbol, and then we look at x plus 2. They really have no GCF, nothing in common, so the best thing that I can do is put a 1 right there. And so if I pull out a negative 1 out of x, I'm left with x, and if I pull a negative 1 out of 2, I'm left with negative 2. And now we look at this, doing magic tricks here. Now we look at this transformed, in a way, polynomial, and we notice that it does have a GCF. There's each term, right, so here's term 1, here's term 2, each term has an x minus 2, so we're going to pull that out, and if we pull that out, we're left with x squared minus 1. Alright, and so then we're going to apply the zero product property, which says x minus 2 equals 0, and x squared minus 1 equals 0. And now we use our 7th grade math skills, x equals 2, and we got to pull out some 10th grade math skills here also, where we have x squared equals 1. We remember that we take the square root of both sides, so x equals positive or negative 1. So there are our 3 roots, 2, 1, negative 1. Alright, so first skill that you got to keep at the back of your mind is, hey, maybe I should try factor by grouping. Alright? So I want you to do example 1. Go ahead and try those, and then pause this, try them, they're in your notes, and then check back in. Alright, so same idea. These both have an x squared, so I'm left with x minus 3. Bring down the negative. I can pull a 4 out of each one, so I'm left with x. Oops, I pulled out a negative, so I'm left with x minus 3 equals 0. So I'm going to have x squared minus 4 equals 0. And x minus 3 equals 0, because that was x minus 3, and then the leftovers were x squared minus 4. Alright, so I'm adding 3, so you should have got x equals 3, and x squared equals 4. You take the square root of both sides, so x equals plus minus 2. There are the 3 roots that we're expecting to see. Alright, here we go. Again, x squared, x plus 5, bring down the negative, they both have a 5, x, we pulled out the negative, so we have x squared minus 5, and x plus 5 equals 0, set both equal to 0, add 5, we get x squared equals 5, take the square root, So we have x equals plus minus root 5 and x equals negative 5. So there are three roots as expected. Alright, so that's skill number 1. You can always factor by grouping. And more magic tricks, sorry about that. Alright, so that hopefully wasn't too bad because you learned it last year. So now what if you can't factor by grouping? And you encountered this last year, right? That you came to a point where you just could not factor by grouping. Well, you couldn't solve by factoring. And you learned more skills. You learned the quadratic formula. You learned completing the square, right? So same idea. This right here is the master plan, okay? So solving polynomials of any degree can be a little bit tedious, but if you have a plan, you can get through anything. Okay, so we have to solve this guy right here, example 2, part A. I analyze it, I can't factor by grouping, but through a quick look, I notice that they all have an x. So I know I can plot an x. Okay. Alright, so, I mean, technically, I already have one of the 4 solutions. X is going to be equal to 0. And you're going to see why in a second if you don't realize it right now. But I still got to work on this beast. So solving polynomials is kind of like whittling wood, if you've ever whittled wood. You chip away a piece, chip away a piece, chip away a piece, till you get it all done. So, just a heads up, it is a little tedious. So, be prepared. Right, so we know that we have one out of those factored, and each factor will produce a root. So now we got to work on this stuff in the parentheses. So I cannot factor by grouping, right? Try it, it won't work. So we did learn something that we could maybe do. We learned that we can take our P and our Q, which are the first and the very last number, and we can find factors of each, and we can know that those will be possible solutions. So we're going to jump to that skill. Alright, so we're going to take our P, which is negative 3, and I know that it's going to be 1 and 3 are the only factors. Now remember, I ignore the negatives, and I just account for those at the very end. And the only factors of 1 are 1 and negative 1, but like I said, we're going to use 1 at the end. Alright, so we have 1 divided by 1, which is 1, which means there's also a negative 1. Then we have 3 divided by 1, which is 3, and 3 divided by, and then it'll be negative, right? So these are the 4 possible rational roots. So what do I do with those? I'm going to use the remainder theorem, and I'm going to plug each one of those in until I see if it works. And the reason I'm going to do that is because then I know that it's a factor, and I can then factor it out. Alright, so I'm going to plug in a 1. So I'm going to have 1 cubed minus 5 times 1 squared plus 7 times 1 minus 3. So I have 1 minus 5 plus 7 minus 3. So 1 minus 5 is negative 4. Negative 4 plus 7 is 3. 3 minus 3 is 0. Woohoo. So 1 works. That's very good. What does that mean? Well, that means that x minus 1, right, because remember so we're kind of working backwards from when we did synthetic division, means x minus 1 is a factor. So I'm going to pull it out. Okay, so x times x minus 1 is going to help to create this guy, well, the original. Alright, so I'm chipping away. I know that that is a solution, which means that it is a factor when I move it back to its x minus a form. Okay, now I don't know what the leftover is though. I don't know how to do that, but you do, okay? Alright, so you do because you know how to do synthetic division. We can divide, just like if you're like, oh man, I think 2 is a factor of 52, but I don't know what it multiplies by to create it. Same thing. We know that x minus 1 multiplies by something, but we don't know what, so we're going to use division. Alright, this is why I said it's tedious. It kind of takes a while. So we're going to take the 1, and we're going to synthetically divide it and see what the leftover is. So we have 1x cubed minus 5x squared plus 7x minus 3. We're going to bring down our 1, which gives us negative 4, which gives us negative 4, which gives us 3, which gives us 3, which gives us 0, and leaves us with x squared minus 4x plus 3. X squared minus 4x plus 3. This all equals 0, remember. Alright, so again, what did we do? Go back, let's think about this. So we had our original polynomial, and we noticed that we could factor, so we're really pulling in every single skill we have, every single math skill. So we first looked and saw if we could factor. Boom, yeah, we could. Alright, and then we thought, this thing right here is really big. I don't know how to factor that. I factored out the only thing that I could. So then we remembered the rational root theorem, which gave us some possible things that could factor out. Okay, so once we found that solution, we converted it into its factor, and then we had to see what multiplies by that factor to create the stuff we had in the parentheses, and we used division, just like you would with your calculator if you needed to know what multiplied to create a number. Okay, now, we're still not going to, you're not done factoring until you have no more exponents. I mean, there's always an exponent of 1, but you know what I mean, there's no more exponents there. Alright, so we're going to see if we can factor this one by hand, or use the quadratic formula. Whenever you get down to a quadratic, you're just pulling out skills from last year. You don't have to do any more of the synthetic division. You could, but you don't have to. Alright, so we're going to think what multiplies to give us 3, but adds to give us negative 4, which is negative 1 and negative 3, right? Negative 1 times negative 3 is positive 3 and adds to negative 4. Okay. So we really had to pull out every math skill that we had, but we have now factored that completely. That is down there, right? This guy right here is the complete factored form, which now when it's in its factored form, we can apply the zero product property. Okay, so we have solution number 1 right here. Solution number 2 right here. Solution number 3, which is just multiplicity, so that one repeats obviously. And solution 4. And we're done. We found every single root, all 4 of them. And that's what we're supposed to do. Alright, so like I said, and sorry for the typo, that's supposed to be equals 0. You're really pulling in every math skill that you have. Alright, let's take a crack at this guy. Okay, so x cubed, x squared, x, 9, 21, 11, can't factor. So last time I could pull out that guy pretty easy at the beginning. I can't this time. So I've got to think, I've got to break this up. I've got to factor this, right? But we don't have any quick shortcut skills like we did with quadratics. So I'm going to have to use the rational root theorem. I'm going to have to think of the factors of negative 11 and the factors of 1. And I'm going to ignore the negatives, if you remember. So my p's and my q's. So I have 1, 11, and I have 1. 1 divided by 1 is 1, negative 1, 11, negative 11. Alright, so these are the possible rational roots. Now I got to figure out which one actually is. Alright, so I'm going to start just kind of looking at it. I don't think one will work, so I'm going to kind of save that for the end. I'm going to try, it might, but I'm going to save it for the end. I'm going to try negative 1. So we have negative 1 cubed minus 9 times negative 1 squared minus 21 times negative 1 minus 11, which is going to give me negative 1 times negative 1 times negative 1 is negative 1. Negative 1 squared is 1 times negative 9 is negative 9. Negative times negative is a positive 21. And then we have negative 11. So we have negative 1 minus 9, which is negative 10 plus 21 is 11. 11 minus 11 is 0. Alright, so negative 1 is a go, right? So if we change that back to that's the solution. So if we change it back, x plus 1 is indeed a factor. So we know x plus 1 is going to multiply by something to create that guy. So what the heck does it multiply by? I don't know, right? No clue, honestly. But I do know that if we divide something, that's going to tell us what we multiplied by, right? So I'm going to go back to that -1, and I'm going to use synthetic division. 1, -9, -21, -11. Bring down the 1, -1, -10, +10, -11, +11, 0. So I have x squared minus 10x minus 11. Great. If you don't believe me, multiply those together and you will indeed get that. Okay? So we're just cracking away at this. So we cracked out the first factor. Now we have a quadratic, which we don't have to do this weird stuff over here because you've learned enough skills to factor quadratics. So we've got to think, what multiplies to give us -11 but adds to give us -10? That one's not too bad, hopefully. And remember, I can only use this shortcut because my a is 1. If not, I'd have to do a longer factoring process. Okay, and then it's going to be, right? Yep. 1 times -11 is -11. -11 plus 1 is -10. Perfect. Alright, so now that it's all factored down to the bones, we can use the zero product property and know that x equals -1 with multiplicity 2 and x equals 11, and those are the 3 solutions. Alright, so go back, look at this. If you need any help, please email me. Try the homework, see how you do. If you've looked at the calendar, we are spending, I just wanted to double check, I didn't put anything else in here. But if you look at the calendar, we are spending 2 days on this, but we're probably only going to spend half a day and then a half a day on the next unit, just a heads up. So there is a quiz today, so try the homework in the module that you found this, and then try the quiz, but please let me know if you have any questions.